Hello, my name is Derek from Tomcat Gas Training and welcome to this video on the installation of an LPG boiler. Now basically this video is for my trainees to help them and give them an introduction on LPG and how an LPG boiler is installed. So if you're not gas safe registered, you should be watching this video. You shouldn't be working on gas and you definitely shouldn't be putting your own boiler in. So if you're a DIYer hoping to get some information on installing LPG boilers, you're going to struggle. But if you're a trainee gas engineer or you're a gas engineer looking to get an introduction into LPG, then this is a video for you. So let's get on with the video. Right everyone, today I'm on site. Going up to Denshaw to see my mate Mike and fit an LPG boiler for him today. So it's not just a matter of fitting his boiler. We're going to do a load of steel pipe work on the outside. So me and Tommy Blood got today and tomorrow to get all this pipe work altered and Mike's new boiler in. Now Mike's a plumber and he's a kitchen fitter and a bathroom fitter, and I taught Mike 20 years ago, and he's just bought this pub, or used to be a pub, in Denshaw. So that's where we're off today. Now today is supposed to be 27 degrees and I've got the old factor 50 for me and Tommy Blood because we're working outside, you know, ginger and all that. So first job though is turn the radio off and let's get to the butty shop and well, it's a local corner shop, and get some grub for today and then get on over to Denshaw. It's only 7 o'clock. Don't normally do 7 o'clock. Anyway, you know, let's get on with it. Now, at the butty shop, got to remember, put my mask on. Do my ears look big in this? This one does, doesn't it? Anyway, let's get to the butty shop. So, got the food. Is it just me, or does everybody feel like a back rubber every time you go into a shop with these on? Went into the restaurant last night and I felt like I was robbing the bloody restaurant. Anyway, take this off now. Oh, that was scary, wasn't it? Anyway, yeah, got the old sausage rolls, McCoy's crisps. You gotta have the chicken and bacon sarnies. Pepsi Max for me. Tommy Blood he doesn't do healthy. He only does full fat Coke. So that's the grub. So finally, I've been on with my bloody keys. Oh, there they are. Let's get on to Mike's. So, arrived at the job, so let's go and have a look on the outside first. So that's the place we were doing the job at today. But what an amazing view. So this is the little beauty we're going to be working on today, and if you can see it, we're going to be replacing that boiler up there, and we're going to be doing some alterations to this pipework you can see here. So the second stage regulator it's got to go there because it's right around the building. So let's go and have a look at the gas pipe. Looks like our Tom's beat me to the job already. Hello, Tomcat. Goodbye, Tomcat. So this is the gas main now. Goes all the way around here, up here, all the way across there, all the way down to the bottom of that building down there, and the regulator's just on the other side of that wall down there. So all that is coming out, and we've got to move the regulator there and then bring it up, and that's where the boiler's going up there. This is the boiler we're replacing, which, as you can see, is an old Boxy or Potterton, one of the two. This is a combi boiler, but we're going to be replacing it with a system boiler because it feeds this cylinder with a few little issues we're going to need to sort out. First one we see straight away is this is your D1, this is your D2, your discharge pipe 2, which should have a ton dish there, so that needs sorting out. And if we follow the D2 down, it goes to 15mm through the wall, so that'll have to be changed. So this picture shows you the correct installation for your discharge pipe 1 and your discharge pipe 2, or your D1, D2. The maximum length you can have for a D1 will be 600mm to the ton dish, and the maximum length you can have for a 22mm D2 would be a hydraulic resistance of 9 meters, which we do actually fall in that category, but it's 15mm when it can have a minimum size of 22. Also, you need at least 300mm from the bottom of the ton dish to the first bend, and we didn't have any of those. So, if we look at the, this is the pipe what goes off and feeds the expansion vessel, and for some reason there's a 15mm pipe coming off that from somewhere. Just need definitely sorting out a little bit in here. But we're not here to do that, we're here to replace that. Now, before we crack on and do the installation of this LPG boiler, let's have a look at the characteristics of LPG and compare it with natural gas. So first of all, LPG stands for liquid petroleum gas. So it's a liquid in its normal state and we draw off the gas vapours. Its chemical formula is C3H3. Unlike natural gas, which is CH4, which is mainly methane. I ain't going to say what that chemical formula is, I might put it at the bottom, it's a bit long. Anyway, I just can't say it. Now, its origins, 60% of it is from extraction from when we do natural gas. So when we're drawing natural gas out of the ground, there's also LPG there. So it's from the old coal fields. 40% of it is produced during the refining of crude oil. So it's a byproduct of crude oil as well. Now, its density, that's the big thing. So it's 1.5 times heavier than air, unlike natural gas, which is lighter than air. So natural gas, if you had a gas leak, would fly away, unlike LPG, which would lie low, which can cause some major problems. So you might not be smelling it because it's down there at the bottom and it's hard to get rid of. So there's no way we would be putting this LPG boiler in a cellar. So, unlike the one what's already installed. Anyway, LPG is odourless and colourless, the same as natural gas, and it has a mere caption added to give you that smell of rotten eggs, the same as natural gas. Its explosive limits though, 5 to 15% for gas in air for natural gas, but we've got 2.1 to 9.5 gas in air for LPG, so the lower explosive limits are a lot lower. It's also ignition temperature is 410 to 580. But the auto ignition temperature for natural gas is slightly higher than LPG, it's about 760 degrees C. Propane boils at minus 42 degrees C. That means it turns into a gas, and that's what we're drawing off this gas, and it freezes at minus 188 degrees C, which is a bit lower, well, a bit higher. You need natural gas free anyway. The combustion formula for LPG is C3H3 plus 5O2 equals 3CO2 to 4H2O. So let's have a look at a few more. Now, last few before you all fall asleep, I promise. So we know between natural gas and LPG, relative density for natural gas is 0.6, and we know LPG is between 1.5 and 2. So we know it's heavier than natural gas and heavier than air. So the gross calorific value for natural gas is 38.76 megajoules per meters cubed, and for LPG it's 93.8 megajoules per meters cubed. Flammability limits we know is 5 to 15% and around about 2 to 10 for LPG. Flame speed 0.36 meters per second for natural gas, 0.46 meters per second for LPG. Ignition temperature, we said 700 degrees C for natural gas, 530 degrees C for LPG. Wobby number between 48.2 and 53.2 for natural gas, and 72.6 to 87.8 for LPG. So Wobby number, what is it? Well, the Wobby number is basically a number given to a certain type of burner, using a certain type of gas. And it uses its calorific value, its relative density, its flame speed and other matters what come into it. So the way you calculate the Wobby number is, it's calculated by dividing the calorific value of the gas by the square root of the relative density. So I've done a little calculation for you. For natural gas, 38.76 divided by 0.77459 is around about 50, and for LPG 93.8 divided by 1.22474 gives us 76.5 for those particular gases, which falls within those parameters. So that's some information on the combustion for LPG differently to natural gas. So I think I've done enough going on now, so let's get back to this video and let's get this boiler installed. And as always, before we touch any gas installations, we're going to make sure we're safe. So we need to do our non-contact voltage indicator to make sure we're not going to get electrocuted. And then when we've finished using it, because we proved it before, we're going to make sure it's still working and prove it again. Now first, let's have a look at this actual tank positioning. So there should be a minimum distance called the tank separational distance between the tank and any buildings or the boundary line or fixed source of ignition. So from the drawing here, you can see the tank needs to be 3 meters away from the building, and it needs to be 3 meters away from any garage, and also 1.5 meters away from any source of power cables going over the top. You can also see the road which is passing at the side of this tank needs to be a minimum of 2.75 meters wide, and that's so the actual tanker can pass up the side of the tank without damaging it. Also, the tank can actually have a boundary wall put around it, but not on all 4 sides. In case of a leak or leaks, there should be plenty of room around the tank to ensure that there is good airflow so that pockets of the heavier than air LPG vapours cannot build up around them. It is also very important to keep the area around the tank free from rubbish, especially if the rubbish is combustible, and it could also reduce the levels of ventilation around the tank. For similar reasons, keep weeds and grass down from around the tank. If you choose to use a weed killer, make sure the weed killer doesn't dry out the weeds, because this will make the dead plants easier to ignite. Now, the way LPG works. So inside this tank, we've got up to 2 bar, and then you can see from here it's reduced to 75 millibar, which then goes across. So there's your main ECB coming out of your tank, comes across here, that's the test nipple there, and then this pipe is still 75 millibars, which then goes across the road to this valve here. Now this main gas pipe running across this road has to be made of MDPE, medium density polyethylene, to BS-EN 7281 or BS-EN 1152 part 2. Now normally a gas pipe laid below a private garden or a pathway with no traffic on it will be laid to a depth of 375 mm. But because this is a private road with the likelihood of heavy traffic such as the LPG tanker, then this pipe should be 600 mm below the ground. Now there should be a test point here, around here somewhere, after this valve, but there isn't. So this is still 75 millibar in here, which then goes along here, and like I say, across there, which then comes to the second stage regulator, which is around this corner here. So where is it? That's the other boiler we're taking out. This is the second stage regulator, and this brings it down to 37 millibars here. So built into these second stage tank regulators are what we call the Upso valve, or under pressure shut-off valve. To reset them, there is a black lever here, or the green in the one we've got. You just pull the lever and it allows the gas on the other side of the diaphragm to allow the gas inside the house when the pressure is dropped for any reason. Then you just put the cover back on and job's done. So there's the second valve. Oh, there's no test nipples anywhere. This is still 75 millibar here. So there's no test nipples. So if you look on this here, you can see this is where we're reducing it then to the 37 millibars to come into the house as it is now. But no test nipples at all. Only the one on the tank. Because the first thing I need to do is I need to test it. But the only place I can test it is at the tank. Now before I do any testing, I need to change my analyzer to LPG, so when I do my tests I don't get mixed up with natural gas with the LPG. So now I can get on with doing the test. Where do you want your coffee? Just there would be great, thank you. Now all the tests have been carried out, we've passed, no drop whatsoever, no passing of the ECVs. It's time to get it stripped out. That's the first unit undone, now we can get it all out.
worst batting sides.
One of the best fielding.
One of the best fielding, shocking.
Oh, have you seen
The worst wicket-keeper I've ever seen.
Yeah, grab that some.
You see their wicket-keeper?
Yeah. Why isn't
Their stuff.
their stuff? What? It's classed as the best bloody one-day opening batsman in the world.
One day. They're just sloggers, Dad, you know they are. What's that? Looks like you tripped it about 100 times.
Oh, God. I never even noticed it.
You can guarantee you're standing down.
Can't believe it. So this is a little workbench I've got set up. First thing I need to do is, using my big foot, is take off this union, the second stage regulator. We need that, and I need to replace it with the other part of the union off the pipe there. So that's nearly ready for us to install. So we're just going to make the fittings in now. So I'm going to use this hot white jointing compound because to third family gases it takes up to 5 bar. So that's what we're going to be putting on. Just going to put it on the thread. Because this is a 3/4 steel pipe, we don't have to use any reinforcement fibre on the pipework. If it was over this 25mm, then we would have to use that inside the socket. Always make sure you leave it on stir first, even though it's just wound up top really a lot. That's why he's laughing in the background. As always when tightening up with using steel pipe fittings, it's the old righty-tighty, lefty-loosey. That's how thick the wall is. So that's a 28 sleeve going through. Don't want to go through now. Oh, there you go. That's the sleeve through. All we've got to do now is get the pipe in. Now, just going to have to put a chamfer on this because we need to put a thread on it. So Tom's just cut through with the hacksaw, so I'm just going to use the battery grinder just to put a bit of a chamfer, so when I use the dies it'll go on a lot easier. But first of all, make sure I put my PPE on. Now the chamfer will help the dies to start a lot easier than if you don't do it, because if you don't chamfer the pipe you're going to be pushing against the blunt end and it'll take a lot of pushing to get the dies started. So always make sure you chamfer your pipe before you use a set of stocks and dies. Now I've put the chamfer on the pipe, it should make it easier to use my stocks and die. So this is the stock and this is the die, to be able to cut the thread. So first of all I need to use some cutting grease. So it goes that way through. Let's move that forward a bit. And then it's just using the ratchet to cut through and making sure I've got two threads sticking through the back of the die, and making sure as I'm going along I'm spraying the cutting grease to cut a nice thread. Now I've got two threads showing out the back, so all I have to do is reverse the dies and take it off, which helps clean the threading. And that's how you cut a 3/4 thread in a piece of steel tube. Just make sure before you apply the actual jointing compound that you've removed all the cutting grease and oil you've used to make the thread, otherwise you could compromise your joint. Well, just this last bit to tighten up, and then that's done. And then we can get inside and get this boiler drained. So that's the pipework installed. Let's get inside and start on this boiler. Because this Worcester 8000 system boiler is quite a heavy boiler and we are fixing onto plasterboard, we've used a piece of ply first and fixed the plywood to the studs and then a jig to the ply. Just a little word of warning when you're fitting these Worcesters. This bracket here, this grey one, comes in a bag and you need to fit it either before you put it in or just take the trap off, which we've had to do, so you can get that one screw in there. But we must have dropped that screw about 10 times. and also it hooks over the back, so make sure you hook it over, and that's the support for the pipe for the blow off. And the O-ring for that is in the bag with all the other nuts and olives. So just a word of warning, when you're fitting an 8000, you need to fit this support bracket for the blow off pipe. So that's what it looks like when you've put it actually in the bracket, and we've got to get it onto that pipe there, which is pretty easy when you're doing a system boiler, hopefully. So this is the problem you get with Worcester flues. So the one at the top is the one I've just taken out, and as you can see, the Worcester one is nowhere near as long. So when you're going through really long stone walls, we need a longer flue. Worcester. Well then, here we go, day 2 of Mike's LPG boiler. So biggest problem we've got is the flue's not coming till Monday, so that's messed up commissioning the boiler because we've got no flue. So we need to get it wired, we need to get the heating linked to downstairs, get that finished, get it filled up, wired up. The gas has been tested, so that's okay, and wait for this flue and any other little bits we've got to do. Oh, we've got to sort the cylinder out as well. We've got to fit the tundish. So let's get on with it then. Well, before I get there, it's time to rob the shop again. Let's go! So we've finished wiring up. Tom's had to wire in extra zone valves because we've had to split the heating system into 2, an upstairs and a downstairs, because the place is bigger than 150 square meters. So we've got a zone for upstairs and a zone for downstairs. So we've had to put a stat for upstairs and a stat for downstairs. So that's all the wiring taken care of. So as you can see, we've put in the new tundish now, and we've increased the size of the D2 pipe. So this D2 pipe now is more than 300 millimeters long. It's now 22 mil, and it now terminates outside the wall. So this is the flue we've needed. It's a lot longer here, but for some reason that's shorter than the other one. But it was still long enough now for us to go through the wall. So when you figured out the length, we need to secure it with the screw, and then we need to put this tape around it to seal it. So that's how you seal a Worcester flue on a telescopic flue. So that's what the finished article looks like. And don't forget to put the internal sealing collar on before you slide it through the wall. And that was the installation of the Worcester Life 8000 system boiler. Now, a couple of things if you're a Worcester lover, or even if you're a Worcester hater. First thing is, this boiler is just like the old CDI Classic really, but it was to replace the CDI Classic. But it is the heaviest boiler I've ever put on a wall. Well, in domestic situation anyway. It is really heavy, and it is really well made and well put together. The casing comes off dead easy. It's just basically one screw and everything pulls off. It's unlike a Worcester. It is dead easy to take apart. Combustion chamber's only got one screw on. The jig was a usual CDI Classic jig, so it was dead easy to install really, other than it being taking 2 of us to lift it on the wall. So just bear that in mind. If you're trying to fit one of these on your own, don't try and put it too high up, because you'll never get it up there. Other than that, it was a dream to wire up. It was a doddle to commission. and a really good boiler. I wouldn't say it was the best boiler in the world, but it's a really good boiler. So you Worcester haters, why don't you try it? Give it a go. An expensive boiler, but a good boiler. So if you've liked this video, why don't you give me that thumbs up or leave a constructive comment down below. If you're not subscribed to our channel, then please subscribe because it helps us along the way. And don't forget to hit that notification bell because we release videos mainly on Mondays and Wednesdays. All I've got left to say is, thanks for listening, thanks for watching, and I'll see you on the next one. Cheers, guys.